Hi, welcome to another episode of Science Made Simple. I'm Dr. Ryan, and I'm a science specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of chemical bonding. I've also prepared this question for you to download for free by clicking a link in the description box below. So let's get started.
Element X forms the ion X2 2- with the following structure. Since we are talking about ions, let's have a quick recap. Can you still recall what are the types of ions that you have learnt? Let us draw a table over here. If you can recall, we have learned about two types of ions. The first being cations, and the second being anions. Now, can you still recall how cations are formed? Cations are formed when atoms lose electrons. What about anions? Anions are formed when atoms gain electrons. One example for the formation of cation would be for sodium. Sodium is a metal and it prefers to lose electrons to form the Na+ cation, whereas chlorine is a non-metal and it prefers to gain an electron to form anions. Now, if you look at the structure of Cl-, this is actually an example of a monoatomic anion. Why do you think it is called monoatomic anion? That's because it is only made up of a single atom. However, if you look at the structure given in the question, this is actually an example of polyatomic anion. What is the meaning of polyatomic anion? As you might have guessed, polyatomic anion simply means that this anion is made up of more than one atom. In fact, besides this polyatomic anion, there are also several other polyatomic anions that you have learnt. Can you recall them? The hydroxide anion is a type of polyatomic anion, and it has the formula of OH-. Besides this, we also have nitrate. The formula for nitrate is NO3-. And another example would be sulfate. Sulfate has the formula of SO4 2-. So these are some of the common polyatomic anions. Now, let us analyze the structure given by the question. The first thing that we notice is that this particular polyatomic anion comes with a charge of 2-. So what does that tell you about the number of electrons that this X2 2- has? This 2- tells us that X2 has in fact gained 2 electrons. Therefore, we can construct a table to summarize the number of electrons before and after gaining these 2 electrons. Next, let us count the total number of valence electrons X2 2- possess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this means that X2 2- contains 10 valence electrons. After gaining these 2 electrons, we have X2 2-. So before gaining these 2 electrons, what do you think is the formula of this species? That would be X2 without the 2-. Since this species has 10 valence electrons after gaining these 2 electrons, how many electrons do you think this species possess before gaining these 2 electrons? That would be 10 minus 2, which is 8 valence electrons. After establishing this fact, we can see that X2 has 8 valence electrons. And we know that in X2, we have 2 identical elements X. And if that makes up a total of 8 valence electrons, we know that for each X, that would be simply 8 divided by 2, which is 4 valence electrons. Can you recall how many valence electrons group 1 elements contain? That would be 1 valence electron. What about group 2 elements? Group 2 elements contains 2 valence electrons. How about group 13 elements? Do they contain 13 valence electrons? The answer is no. Group 13 elements contains 3 valence electrons. Based on this trend, we know that group 14 elements should contain 4 valence electrons. Now, based on this concept, we know that X, since it has 4 valence electrons, must come from group 14. And if you refer to your periodic table, you'll be able to notice that chlorine is from group 17. And using the same method as what we have discussed over here, we will be able to deduce that chlorine has 7 valence electrons. Now, we will need these two pieces of information to proceed on to the next part of the question. The question asks, what is the formula of the covalent compound that X forms with chlorine? To help you to solve this question, let us draw another table that summarizes what we know about X and chlorine. Now, if you can recall what you have learned for covalent bonding, how many electrons do you think the valence shell should have in order for the particular atom to attain stability? Can you still remember the magic number? The magic number is 8 for most of the atoms except hydrogen and helium. So for this case, we have 4 valence electrons for X, 7 valence electrons for chlorine. So how many more valence electrons do you think they need in order to achieve 8 valence electrons? The answer is, for X, we need 4 valence electrons, whereas for Cl, we need 1 valence electron. This also means that X will share 4 valence electrons, whereas Cl will share 1 valence electron. In order to draw the structure, you can pretend that these 4 electrons that X share are like the hands of X. So this is as good as saying you have X with 4 hands. On the other hand, for chlorine, since it shares 1 valence electron, therefore it has got only 1 hand. Now, if you look at the choices that we are given, we can see that they only differ in the number of Cl. So if you look at our structure over here on the right hand side, how many Cl do you think we need in order to connect to X such that there are no more free hands that's left behind? The answer is we need 4 Cl, and we will obtain the structure over here. Therefore, we will need 4 Cl. The answer will be option 4.
Thank you for watching, and I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!